Alright, so we're back again with another video on Golang, and in this one we're going to go over generics. So generics are very useful for when you have a set of logic that you want to apply to different types of data. In those cases where you may have different types of data, you would have to create separate functions for each one, and that would be pretty tedious, and it would kind of make your code just look too messy. So in this case, I have a function that is accepting a string to check whether or not that string is a palindrome. And for me to be able to take in another input, say an integer value, I would have to create a whole separate function to achieve that. But with generics, you don't have to do that. You can define that in your method signature to accept different types of data and then be able to perform that data or perform that logic on those different types of data. And if you're not familiar with palindrome, palindrome is basically a word that is the same when you spell it backwards. And so in my case, for integers, what I'm trying to achieve with that is, be able to do the same thing to see if the number is a palindrome. So heading over to the code, create our function, and we're gonna call it isPalindrome. And this here is where you define those data types that should be allowed to be passed in. So it should either be a string or it should either be an integer. And then you define the name of the parameter type, which I'll just put input, and then you define the name or define the data type that that input should be. So in our case, t, and then t represents string or integer. And then from this, we're going to return a Boolean. All right, so when I'm taking in a string and an integer, this function will accept it, no problem. But when I want to go ahead and start implementing my logic, I'm going to be handling an integer a little differently than a string. Because with a string, I'm going to be able to go through and look at each index and see whether or not the value is the same on either side. But with an integer, it's a little tough to do that. So I'm going to convert my integer into a string. And to be able to tell whether or not my input is an integer or a string, I can use a type switch that Go has. So a type switch is basically a switch statement, like any kind of regular switch statement. In this case, it is a switch statement that tests whether the interface value I, and in our case input, holds a value of t or s, which in our case would be an integer or a string. And in each case, or in each of the t and s cases, the variable v will be of type t or s. So after it checks here to see what type it is, it's going to assign this variable v the value of either t or s. And then it's also going to hold the value that I has been passed into, or passed in. So this allows us to be able to check the type and at the same time assign that type and the variable value to this variable v. So we'll just take this over here and then modify it for our needs. So since this is an interface, it's requesting that I prefix it with NA so that it can perform its type assertion. And let's make sure we change that to input since that's what we're passing in. And then now we're just going to change the logic that's inside of these case statements. So I want to be able to convert this integer into a string. So I'm going to go ahead and do that and assign it to a variable called text using the string conversion package and ITO function. And then we just go ahead and pass an integer, and then that integer will be then converted into a string. So we're passing in that v variable that was created here after it checked the type and then it performed its type assertion. And since text does not exist yet, I need to go ahead and define it up here. So text equals, and we'll say just an empty string. And it's complaining right now because text is not used or is not guaranteed to be used inside of this switch statement yet. If I were to use it down here in default, then it would for sure be executed within our code. But I'm not going to do that because text is going to be used later on throughout the project. So for string, it's very easy. We're just going to take text and assign it to v. No conversion is needed because it would be a string to a string. So that's it for the switch statement. And then now we're just going to go ahead and implement the palindrome logic. So in theory, after creating this function here at the top, we'd be able to get rid of this isPalindrome string function because the same logic would be here in the top and it would achieve the same thing. All right, so the next thing is I had some code here that was converting all the letters to lowercase for the string. Just in case, I had uppercase or lowercase letters, there would be differences in the two, so I just wanted to make sure that everything was consistent. And then I'm also taking all of the punctuation out of the string as well. So I'm just going to take this and put it inside the case for the string because in a number or in an integer case, it's not really needed. All right, so then I defined a variable called left pointer and a variable called right pointer. So my pointers are basically representations of the index of where I'm currently at in the string. So I'd start off with the first index and the last index and compare those values at those indices to see whether or not they're the same. And I would just keep going further in as I loop through, and you can see down here is where I'm looping through. As I iterate through the text, it would just keep coming in and checking to make sure what each letter on either side is the same. But before I come down there, I'll just explain this here. So I have it set to check whether or not the length of the text is 1, because if the length of the text is 1, that would mean there's just like one letter or one number. So I wouldn't really need to do any further logic on that. It would already be considered a palindrome. All right, so I have this logic down here, the for loop, and it's checking to see whether or not the left pointer is less than the right pointer. So that just makes sure that we're breaking this for loop at the point where they both become equal. Because then when they become equal, that means we're right there in the center of the text, and that means that the string would be a palindrome if it reaches it before exiting on this false. So this false statement would be returned if the left pointer's value and the right pointer's value were no longer equal. If either one of those letters is not the same, then it would return false, and it would say, it's not a palindrome. If that doesn't happen, it'll just increment the left pointer to move further in on the text towards the center, and then the right pointer would be decremented to come closer to the center, checking, and then we'd make that comparison again to see whether or not those values are the same. And if it iterates through this without hitting the criteria for the false statement, then it'll just go ahead and return true, and that'll let us know that our input was a palindrome. So let's just go ahead and implement that code over here. But before we can, we need to import the package. So we're just going to name it pal, and then it's going to be challenges, internal, and then palindrome. All right, so now we have that set up to be imported, and it's going to create print statements to just test our function. So we'll do pal dot is palindrome, and we'll put in race car. And I'm just going to copy the same thing and just create 2 more statements. This one will actually pass in a number to test that integer feature, and then we'll pass in my name, which would not be a palindrome. All right, so the next step would just be to go ahead and run it. So go run, and then cmd, and then app, and main.go. All right, so there you go. You see that it's coming true, true, race car is true, 1221 is true, and then my name is false. So yeah, that is how you would implement generics in Golang. I hope that was helpful.